We'll move on to finding the equations of tangents and normals and all that, and then we'll be done. All right, so let's see if we can do this. What is the slope of the line tangent to f of x equals come on 3x minus 2x squared. Jeez, really? At, let's do x equals 0. Okay, so to answer this question then, I got to do that whole limit business again with h, right? So we're going to do the limit as h approaches 0 of f of, so in this case, because I want it when x is equal to 0, it's going to be 0 plus h minus f of 0 all over h. Okay, so let's start plugging some stuff in. This is going to be essentially then just f of h, right? So we've got the limit as h approaches 0. F of h would be 3h minus 2h squared. And then what's f of 0 for this? It's not meant to be a difficult question. What's f of 0? 0, right? Okay, so minus 0 all divided by h. All right, so we simplify and all of that. Limit as h goes to 0 of 3h minus 2h squared over h. You guys all see how that's going to cancel now with the h's again? Okay, each term's going to lose an h. So limit as h goes to 0 of 3 minus 2h. Now that I have things canceled, what's my answer? 3. So on that particular graph, at x equals 0, we should have a tangent line that has a slope of 3. Okay? So answer me this. This is something we'll talk more about later, though. At x equals 0, is the graph increasing or decreasing? How do you know? It's a positive slope, right? If the tangent line would have had a negative slope, it would be decreasing at that spot, right? And if the tangent line has a positive slope, it means you're increasing at that point. So this instantaneous rate of change business is going to open up a lot of doors for us in some things that we can say about functions. See if you can answer me this then. What would you expect the slope of the tangent line to be at a maximum or a minimum of a function? 0. That's going to be a huge connection we're going to talk about in the next chapter. Is if we know that the slope of that tangent is 0, then we can identify maxes and mins. In pre-calc, we talked about maxes and mins. We were never able to calculate those things by hand. We always had to look on a calculator to do it. Now you guys have the means to do it by hand. You can figure out where all the maxes and mins are of a function simply by knowing that if you can get the tangent line slope, you should be looking at 0 for each one of those. Okay, and that's something else we're going to do with this later on too. So, okay, so I think we're good with that. So now, can we take it a step further, and can we actually come up with the entire equation of that tangent line? Because it's a line, right? And all lines have equations. So let's see if we can do it. So if we have some curve, okay, and let's say we're looking for the tangent at this particular point right here. We'll call it A. And our tangent line is doing something like this. Okay, and I want to find the equation of that line. Well, we've already found out, or we've already talked about a method to find one piece of information about that line. Its slope, right? So we just discussed the slope of this is the instantaneous rate of change. And what else do we really know about that line that we can use to help make an equation for it? Think about the very first section we studied in this class. It was all about lines, right? What do we need to make an equation of a line? If we could use a y-intercept with slope. That's one way, but we don't have a y-intercept, so we're kind of stuck there. What else could we use? A point. Didn't we do that, right? If we had a slope and a point, that was enough, right, to make an equation of a line? We have that, don't we? Where's the point? Right there. Okay? So our point we're going to use is a f of a. Okay, we got to plug in a to get the y, but yeah, so a f of a. So we got a slope, we got a point. Good enough, we can do it. We can go back to those techniques we talked about before. So let's try that. See if we can do it here. So what is the equation of the line tangent to f of x? So we'll just keep it simple for this one. How about just x squared? And we'll do it at x equals 1. All right, so unfortunately, we do have to do all of this instantaneous rate of change limit as h goes to 0 stuff every time we do this, because that's how we're going to get the slope. But after we've got that, then it's pretty straightforward. So we're going to do f of 1 plus h minus f of 1 over h this time, right? Because we're finding it at x equals 1, so 1 plus h and 1. All right, so 1 plus h squared is 1 plus 2h plus h squared. And then f of 1, well, what's f of 1? 1, okay. Are you guys to the point now where you could do the next two steps in your head? We've done enough of these, or maybe you can start doing that. See if you can follow me here. 1's will cancel, h's then will cancel. I'm left with 2 plus h. Right? 1 minus 1, those are gone. Cancel out h's, and we got 2 plus h. So what's the slope? 2. All right, so slope of our line is 2. And a point that it goes through. Well, we were looking at x equals 1. So 1, what's f of 1? That's the y-coordinate of this point. What's f of 1? 1. So we need to make a line that has a slope of 2 and goes through the point 1, 1. So y equals 2x plus b. Now, if you like point slope form, by all means, you can do that too. This is just the way I think most of you guys did it. So we can take the 1 and the 1, x, y, plug them in. 1 equals 2 times 1 plus b. So b equals, what, 1 minus 2, so negative 1. So the equation of our tangent line is y equals 2x minus 1. Okay, and the only other thing I really need to go over with you guys, and then I think I'm good to go here with you, is a normal line. Now, depending on the context, and we'll get to some application stuff like in Chapter 4 where we'll talk a lot about this, but there are some instances where we want to know what's the equation of a normal line. Well, we need to talk a little bit about what a normal line is. Any of you guys in physics? You guys know what the normal force is? What is a normal force? A force that is perpendicular to the plane, right? So a normal line, rather than being tangent to the curve, it's perpendicular to the curve. Okay? So if we had a little function going along here, let's say I wanted to find the normal at this particular point right here, what I would do to sketch that here, here's your tangent line. And so the normal line would simply be perpendicular to that line through that point. Okay? So the normal would go something kind of like this. So this one is the tangent, and this one is the normal. What is the only thing that's going to change about this process if I want to find the equation of a normal line? Yeah, exactly. The slope's going to change, right? It's going to be the negative reciprocal of whatever the tangent was, and then continue. So you still got to do that difference quotient. You still got to do that limit as h goes to 0, etc., etc., etc. Do that process out, but then take your answer and change it. Make it a negative reciprocal, and then continue on. So to save a little bit of time here, let's go back to the last example, except just change the directions and make it normal line instead of tangent line. Okay? Because we've already done the hard work of figuring out the slope of the tangent. Okay? Our tangent slope we already found was 2. If the tangent slope is 2, what's the normal slope? Negative 1/2. Good. And again, don't we still have a point it goes through, right? The tangent and the normal both go through that same point. So we use the point 1, 1 in getting the equation of the tangent, so let's use the point 1, 1 again to find the slope of, or to find the equation of the normal. So we're looking at an m of negative 1/2, a point 1, 1, okay? So y equals negative 1/2 x plus b. So if we plug in the 1, 1, 1 equals negative 1/2 plus b. So b equals, if I add a half to 1, that's 3/2. So my normal equation then is y equals negative 1/2 x plus 3/2. So I can do that too. I can figure out the equation of that normal. All right. Any questions about any of this stuff, guys? Yeah? How did I get the 3/2? I have to add 1/2 to the other side, though. So, all right. So to recap a little bit with you, the big concept, average rate of change, slope of secant line, same thing. Instantaneous rate of change, slope of tangent line, same thing. Okay? The rest of it is just working with linear equations like we've done in the past. So, all right, I'm going to let you guys get to it here.